Welcome, this is Mr. TG. This is video number 2 from lesson 6-7, finding inverses, in this case of quadratic functions. Again, we're going to try and hopefully build on what you already know how to do. What I want you to do is take this function right here that I provided you, and our objective will be to graph this function and its inverse again on the same grid. So what I'd like to have you do is graph the function that's provided on the grid. Hopefully you know by now that's going to be a parabola. Find its vertex, find 2 points in each side of the vertex, and then fill them into your table here. And then we'll find the inverse of that function. So good luck. Okay, welcome back. You see what I put in green? That is the function. It's quadratic. It forms a parabola. Our vertex was at 0, 3, or 0, 2. There was nothing inside parentheses, so our x-coordinate of our vertex was 0, our y-coordinate is 2. And then I used the reflection symmetry here, 1. When I put 1 in for x, I got 3, -1, 3. And you can see a parabola is formed. Now what I would like you to do is graph the inverse of that parabola, or the inverse of that quadratic function. Again, what you're going to do is make a table of values over here. Just reverse the order and sketch them on the graph, and we'll discuss your results when you're done. Okay, welcome back. Hopefully you had no troubles finding the points, which are just the reverse of the original. 6, -2, 3, -1, 2, 0, 3, 1, 6, 2. It forms the sideways parabola. Now, this sideways parabola does not pass the vertical line test. This is not a function. The green parabola is a function because it does pass the vertical line test, but the red does not. So by finding the inverse, we've created a graph that does not fit the requirements of being a function. You can also see that it basically reflects over the y equals x line, which is listed there in blue. Now, if we're going to find the equation of this red function, the sideways parabola, we first write down the original, which is y equals x squared plus 2. You then, of course, as the inverse does, reverse the order of the x and y, and you end up with 2. X squared equals y squared plus 2. We subtract 2 from both sides. So that's going to give us x minus 2 equals y squared. And then eliminate the exponent of 2, we square root both sides. So y becomes, now we do generate 2 answers here, plus or minus square root of x minus 2. That is the inverse equation that's listed in blue. Now the last thing I should point out to you would be the domain and range of both of these functions. For the green function, or the first function, your domain, remember what domain is. It's all the values I can put in for x. That's all real numbers. Domain is all real numbers here. So I can essentially put anything I want in for x that I would like. The range, however, does have some limitations. We only can get values for y that start at 2 and go up. So our range is y is greater than or equal to 2. Now, I point this out because if you look at the inverse function, our domain of the inverse and the range have also been switched. So our domain is the x values have to be greater than or equal to 2. Notice that was the range over here. And our range is all real numbers. All real numbers. So not only do the x and y values switch around, and not only do the equations change a little bit when we switch the x and y's around, but our domain and range also switches. So there's an example of how to find an inverse of a quadratic equation. Hopefully that went well. That's video number 2 for section 6-7.